Hello everybody, today we will be learning about projectile motion. Projectile motion is basically the motion under the influence of gravity. Is that we can use vector components to analyze motion. Just simply break up the motion into x and y components and treat them separately. An example that will help us through this will be a man throws a rock off a 90-meter cliff with a velocity of 25 meters per second and at an angle of 40 degrees. How far from the base of the cliff will the rock land? Step one would be to draw out the problem, because drawing out the problem really helps us visualize what we are doing and what we are trying to solve for. And as you can see here, I drew out the man throwing out the rock at a 40-degree angle with an initial velocity of 25 meters per second. And step two would be to try to figure out what are we trying to find. And as you can see here, the problem states how far from the base of the cliff will the rock land. So this is telling us that we are looking for the distance between the base of the cliff and how far the rock gets. And we are calling this distance dx, and that is what we are going to try to solve for during this problem. Step 3 is to identify all given information, and we will be dividing it into an x and a y section. The x, which will be for the horizontally, and y, which will be for vertically. And we already know the hill was 90 meters up, so dy distance vertically will be negative 90, since the stone will be falling 90 meters down. We also know that ay is negative 9.8 because gravity is 9.8, but since the object will be falling downwards, it will be negative 9.8. And we also know that ax equals 0, and VIY is 25 meters per second sin 40, because sin is opposite over hypotenuse, and VIX will be 25 meters per second cosine 40, because cosine is adjacent over hypotenuse, and that is where they are located when you put them next to the triangle. Step 4 is to choose an equation out of the uniform acceleration card, and since I don't want to deal with quadratics right now, I will choose the last equation and try to solve for v final y. And this takes us to step 5, trying to solve for v final y. Solve for v final y is just using the equation vf squared equals vi squared plus 2ad. And since we have squared in the answer part, the part we are trying to get vfy for, we will square root both parts of the equation so that the square root will cancel out the square, and we will just plug in our numbers from there. So we will plug in 16.06 for VIY, negative 9.8 for AY, and negative 90 for D. And from there we will go on, and we will go on to get VFY equals 44.96 meters per second. Now that we have solved for VFY, we can finally go over and try to solve for T. And we will try to solve for T using the first equation from our card. And that first equation is VF equals VI plus AT. We algebraically make it so it's T equals VF minus VI divided by A. And we plug in the numbers for VF and subtract it minus the numbers of VI divided by the number of acceleration, which is negative 9.8 meters per second squared. And using that we get time, and time turns out to be 6.226 seconds. And now we can finally go on to the next part of the problem. Now that we have solved for time, we can finally go over to the x side of the problem, and since time is the same for both y and x, we can just move 6.226 over to the x side, and now we can finally solve for dx. because we only need 3 parts to solve for dx. So that is what we will do with dx equals vix t plus 1/2 ax t squared. So we will plug in the numbers for vi, which is 19.15, and for t, which is 6.226 seconds, plus 1/2 0 for ax, and 6.226 for time. But since ax is 0, we can easily get rid of that, because that will get rid of that and eliminate that whole side of the problem. And now we are left with just 19.15 meters per second times 6.226 seconds, and that gives us 119.22. And now we have solved a projectile motion problem. Thank you for watching.